In the spring of 1942, something extraordinary moved through the forests of occupied Europe. 5 trains, hundreds of flatbed cars, thousands of soldiers, all of it for a single weapon, the Schwerer Gustav, 1,350 tons of steel, a barrel the length of 10 buses, a shell heavy enough to crush a tank before it even detonated, the most powerful artillery piece ever fired in combat, and yet, it failed. The story begins not with a weapon, but with a problem. In the 1930s, France had constructed the Maginot Line, a fortified wall of steel and concrete stretching hundreds of kilometers along the French-German border. Germany needed a way through it. The German army approached the firm of Krupp with a seemingly impossible requirement. They needed a gun capable of destroying reinforced concrete bunkers from a distance of 35 kilometers or more. The shells had to penetrate at least 7 meters of reinforced concrete or 1 meter of solid armor plate. Krupp's engineers got to work. What they designed went far beyond anything that had ever been built. The gun that emerged from their calculations was so large it defied conventional engineering logic. It required an entirely new approach to manufacturing, transport, and deployment. Gustav Krupp personally oversaw the project. The weapon was named in his honor. A second gun built on the same design was named Dora, after the wife of the chief engineer. History would use both names interchangeably. To understand what made this weapon extraordinary, you have to start with the numbers, and the numbers are almost impossible to believe. Fully assembled, the gun measured 47.3 meters in length. That is roughly 8 M4 Sherman tanks placed end to end. The barrel alone was 32.5 meters long. The caliber, the internal diameter of the barrel, was 807 millimeters. For context, most heavy artillery of the Second World War fired shells between 150 and 210 millimeters. Gustav fired shells nearly 4 times wider than the heaviest conventional guns of the era. With the barrel lowered into the loading position, the weapon stood 11.6 meters tall. The carriage alone was 7.1 meters wide, so wide that the gun required 2 pairs of parallel railway tracks simply to stand on. The barrel assembly weighed 400 tons. Total weight of the complete weapon, 1,350 tons. More than a fully loaded passenger train. It ran on 40 axles, 80 wheels, just to distribute that weight across the tracks. Moving this weapon was an operation in itself. The gun had to be broken down into approximately 25 major components for transport. That required 5 dedicated trains just for the gun. A 6th train carried the crew, equipment, and supplies without destroying them. Before a single component could arrive, engineers had to construct 4 parallel railway tracks at the firing site. The 2 inner tracks supported the gun. The 2 outer tracks were used by massive portal cranes, manufactured by the Ardelt Works, which lifted the heavy components into position. The sleepers beneath all 4 tracks were closely spaced and reinforced with iron grids. This was not a precaution, it was a necessity. The recoil force generated by a single shot was so violent that without reinforcement, the track bed would have been destroyed with the first round. Assembly followed a fixed sequence. 250 workers operated simultaneously. First, the left and right chassis halves were mounted on their bogies. Then the central connecting piece. Then the barrel cradle. Then the barrel itself, in 2 sections, joined by a massive threaded coupling at the center. Finally, the breech block, the loading platform, the recoil cylinders. From the arrival of the first train to a gun ready to fire, 6 weeks. Every single time. The Schwerer Gustav fired 2 primary shell types, and both of them were extraordinary objects in their own right. The high-explosive shell was the lighter of the 2. Including the propellant assembly, the complete round measured 8.26 meters, roughly the length of a London double-decker bus. The shell itself weighed 4,800 kilograms. At the tip, a ballistic nose cap made from silumen, an aluminum alloy, improved aerodynamics and concealed the nose fuse. A second fuse sat at the base, reducing the risk of a dud. The bursting charge consisted of RDX and nitroguanidine, weighing approximately 400 kilograms. The RDX detonated first, triggering the less shock-sensitive nitroguanidine. 3 pairs of sintered iron driving bands were fitted around the shell. These engaged the rifling, the spiral grooves cut into the barrel, imparting spin and stabilizing the shell in flight while sealing propellant gases behind it. At maximum propellant load, the shell left the barrel at 820 meters per second. Maximum range, 47 kilometers. Upon impact in firm ground, it produced a crater 12 meters wide and 12 meters deep. The armor-piercing shell was heavier, 7,100 kilograms, nearly as much as a P-47 Thunderbolt fighter aircraft. It carried only a single base fuse, keeping the hardened nose intact for maximum penetration. Testing showed it could punch through 10 meters of concrete, 7 meters of reinforced concrete, or roughly 1 meter of solid armor plate. Loading the gun was a choreographed industrial process. The shell was lifted from ammunition wagons on the rear tracks by 2 hoists, rolled onto the loading trough, and driven into the chamber by a motorized rammer. The propellant bag charges followed. Then the cartridge case. 920 kilograms of nitrocellulose powder in a steel casing sealed the chamber. The breech swung shut, locked. The barrel rose to firing elevation. The ammunition wagons cleared the area. The entire crew withdrew to covered positions, several hundred meters away. Then silence. The firing command was given remotely. An electric firing pin struck the primer. And then, the pressure wave shattered windows kilometers away. The report was audible at 35 kilometers. Soviet partisans in the surrounding hills thought the Germans were conducting demolition work. They had no idea they were hearing artillery fire. Somewhere between 38 and 47 kilometers away, a shell weighing nearly 5 tons was arcing silently through the sky. The Schwerer Gustav saw its most significant combat use during the German siege of Sevastopol in June 1942. Soviet defenses in Crimea were among the most heavily fortified positions on the Eastern Front. Gustav was brought in to break them. One of its primary targets was an underground ammunition depot at Cukrnaya Balka, referred to by the Germans as White Cliffs. The depot was buried deep beneath the earth, protected by layers of rock and reinforced concrete. Conventional artillery could not touch it. A single armor-piercing shell changed that. It penetrated the earth, reached the depot, and detonated. The explosion collapsed the entrance, destroyed surrounding structures, and capsized a small steamer anchored nearby in the harbor. In the right circumstances, against the right target, Gustav was genuinely devastating. But those circumstances were rare. For all its power, the Schwerer Gustav was a failure, not a technical failure, an operational one. Under ideal conditions, the gun could fire 1 round every 19 minutes. In actual combat, that stretched to 45 minutes or more. On its busiest recorded day, Gustav fired just 16 rounds. A conventional battery of field howitzers could have fired hundreds in the same time. Accuracy was a persistent problem. At Sevastopol, only 10 rounds landed within 68 meters of their intended target. For a weapon of this size and cost, that was a damning result. The barrel wore out rapidly. The original service life estimate of 300 rounds was revised down to just 100 after examination of the worn rifling. Each replacement barrel was enormously expensive and time-consuming to produce. The total cost of the weapon was approximately 10 million Reichsmarks. That was the equivalent of 250 heavy field howitzers, or 40 Tiger I tanks, or nearly 2,000 V-1 flying bombs, for one gun that could fire 16 rounds on its best day. And then there was the question of secrecy. Moving 5 trains through occupied Europe and spending 6 weeks constructing a firing position made concealment virtually impossible. The Allies always knew Gustav was coming. The Schwerer Gustav had been designed for a style of warfare that no longer existed by the time it was ready. The slow, methodical siege battles of the First World War. By 1942, warfare had moved faster than any railway gun could follow. Dora was disassembled after the war and never fully reassembled. Its components were scattered across Europe and eventually scrapped. No complete example survives today. The most powerful artillery piece ever built left behind nothing but photographs, craters, and a question that still lingers. Was it ever really a weapon? Or was it simply a demonstration of what happens when engineering ambition loses sight of military reality? If you want to see another weapon or history building that pushed the boundaries of engineering even further, check out our channel. The link is right here. I'm Irene Claps. This is History Things channel. We'll see you in the next one.